Hello, welcome to today's Analyst Webinar Roundtable event. SDN drives new SLAs across data center WANs, brought to you by our sponsor Velo Systems and GigaOM Research. The topic for today is applies software-defined networking specifically to the WAN, and we're going to dig into the advantages and use cases for thinking about software-defined networking in the context of the wide area network. We'll start with a round of introductions from our panel and a message from our sponsor, and then we'll get into the heart of this topic. You'll see there's a place to ask questions as we go through the webinar. Feel free to type in questions as you go. We'll probably take most of those at the end. There's also going to be a couple of interactive polls throughout the session, which we'd invite the audience to take those polls, and then we'll discuss the results live here on the webinar. They're obviously not a huge sample size, but it's nevertheless still interesting from a conversation standpoint. My name is Jo Maitland. I'm the Research Director for our Infrastructure Practice at GigaOM Research. I'll be your moderator for today. And next up, Lee, could you say a few words?
Sure, thanks. Lee Doyle, I'm Principal Analyst at Doyle Research, and Doyle Research focuses on the evolution of the intelligent network, SDN, NFV, and COTS.
Thanks, and Mark?
Mark Leary, Chief Analyst of First Tracks, and research focusing on software-defined networking.
Thanks, Mark, and Ashish?
Thanks, Joe. My name is Ashish Shah. I'm the Director of Product Management and Product Strategy at Vello Systems. I've been in the industry in product management and engineering roles for over 12 years, both in startups and large organizations.
Thank you. And over to you, Ashish.
Thanks, Joe. So I'll spend a couple of minutes on this slide on who Vello is and what we do. So Vello's mission is to transform IT environments through self-optimizing and application-directed solutions. And we want to do that around an open hardware ecosystem. In terms of the history, we've been around since 2009, and we have a metro optical solutions heritage. And this optical networking background actually has been the perfect launch point for Vello to participate in the OpenFlow-based SDN movement, because as you know, in optical networking, the control plane is by definition separated from a data plane. So we've been a charter member of ONF since 2011, and we continue to lead data center-focused optical solutions in the ONF working groups. In terms of the customers, we've been in production with the top US bank, with top hedge funds, trading firms, and financial services networks. We are very focused on unifying Ethernet and optical solutions for the data center market. Our initial focus has been at the edge of the data center and for the active data center solutions for both large enterprises as well as for data center hosting providers. We are an EMC Select partner, and our solutions have been qualified by EMC eLabs for EMC Dplex, SRDF, and recover point offerings. And you'll see a little bit more about that in the near future. We're headquartered in Menlo Park, California, and we recently launched a large development organization or development office in Belfast, Northern Ireland. And so we continue to grow very aggressively across both offices. Next slide, Joe. Thank you. So on this slide, I'll spend another couple of minutes on our solutions, just to give you an idea of the Velo's open networking solutions that's been generally available for a few months now, and it's been deployed in multiple customer environments. We publicly announced two of them recently. One is Equinix, and the other is in Hudson Fiber Network, or HFN, which both of them have installed both our Ethernet and optical unified data center solutions based on Velos. So the core of our solution is Velos, which is a real-time Linux operating environment, which is an open, scalable, programmable, and automated platform with the goal to unify all forwarding planes, virtual, optical, Ethernet, which is the true spirit of OpenFlow and SDN. We are building a rich ecosystem of hardware partners, both on the Ethernet side and on the optical side. The current list includes Centec switches and Broadcom Trident Plus based Acton switches on the Ethernet side. You'll see a lot more partners being added to this list in coming weeks. We'll also partner with virtual overlay solutions providers as a way to provide a physical underlay using Velos. Again, you will see more details coming out on that. The goal of the Velo's network operating system is to abstract the underlying network into a pool of resources. You will see some of that in the discussions today. We offer differentiated SLAs based on bandwidth, latency, and other parameters. And it provides a full feedback loop from the visibility and data analytics flowing up the chain to the controller, making decisions based on policies and based on the analytics, and then driving end-to-end control, whether it's a physical Ethernet network or an optical network, to provide that continuous dynamic feedback loop. Over to you, Joe. Thank you.
Thank you. So Mark, just to sort of help people, stepping back a little bit here and looking at the big picture, can you start us off with a sort of the basics of what SDN is?
Yeah, sure, Joe. And without taking up the whole hour, but in general, SDN, the software-defined networking, is an approach to networking that changes the traditional, and to a certain extent, it corrects some of the ills of the traditional network. That is, it simplifies deployments and operations and such. Certainly makes enhancing the network a lot easier. Also drives higher utilization rates of attached resources, not only attached resources, but even those resources that make up the network. Bandwidth, for instance, is a perfect example in the WAN. It's a very large expense item for the networking budget, and certainly one that if we better utilize the WAN, we'll be better off. And finally, it brings improved dynamics to the network. Networks are traditionally kind of a set-it-and-forget-it utility. You put it in place, it works appropriately the day it's put in place, and until it's showing signs of breakage or signs of age, we tend not to touch it. In the SDN environment, dynamics are more of a continuous process. So that those dynamics are really key to making software-defined networks easier to use and certainly improve the utilization of resources in the years to come. Relative to structure, you certainly see from today the network kind of dictates how application performs, and the resources associated with the network dictate to a great extent the service levels associated with those applications. In the years to come with SDN, as we transition more to a software-controlled network environment, that is, the applications start to direct how the network is utilized. So you turn from a kind of a bottoms-up, if you would, control structure for the network to a top-down control structure. And that goes to not only business applications, but also systems applications in incorporation of more analytics to drive more real-time reconfiguration of the network and such.
Great. Lee, would you add anything to that?
No, and I think in this context, Mark gave a great overview. Looking at how the SDN is going to impact various parts of the network. It'll have different impacts on the data center, on the wide area network, and in the telecom network as well. So it's important to note.
Yeah. So the focus of this webinar is to sort of understand specifically where this plays in the WAN. So what's been the challenge, I guess, in the past with wide area networks, and how does SDN sort of improve things in the WAN per se?
So in today's wide area network, you basically nail up a specific circuit. It will have a specific service level agreement. It will have a certain bandwidth, certain capabilities. That could be something traditional as frame relay. It could be a Lambda, Ethernet, internet services, wide range. But you have what you have, and you can't. It's difficult to increase the bandwidth. It's difficult to prioritize your applications to apply quality of service. It's not necessarily easy to manage. It's not necessarily easy to program. And so that's where we have today's network. And then it also, you sort of have two choices, right? You can run your network over your own optical fiber or optical fiber that you have leased, or you're relying on a specific service provider, and that typically in the U.S. might be Verizon or AT&T to provide that specific internet or frame relay or Ethernet service for you.
Got it. So I'm curious to understand, Ashish, maybe you can weigh in here too. Like, what does software-defined networking kind of do for the wide area network?
Sure. So yeah, in the spirit of, again, separating the forwarding plane from the control plane and decoupling the hardware and software innovation cycles, you give the customers the ability to choose the best hardware that's required to support the performance and capabilities, and then choose software that is best suited for application integration. And do so as long as you do those three through open standards, you can get best of breed solution. So that's one point. The other point is the logical centralization of control now gives you end-to-end visibility. So as we just discussed, that if you have to rely on somebody else's network through which you don't have any visibility, you are at the mercy of the underlying network's behavior and performance. With SDN, though, that intelligence and control is logically centralized, and you can effect a change based on changing behavior or requirements of the applications in a dynamic way. You can carve out bandwidths for different application flows. If there is a failure, for example, one of the two fibers is cut, how do you know which application flows have to be prioritized over the other, and so on. So you can offer deterministic applications SLAs and do so in an automated way. I think that's a third important point in the spirit of SDN, which is there is no more manual point-by-point provisioning for your Ethernet network, for your optical network, for your WAN circuits. You can do all of that in an automated way through the central point of control. So that's why it drives flexibility and innovation through these characteristics.
So I want to get into the details here of the use cases, which I think is where this gets really interesting. Ashish, maybe start us off, like, how do you guys define an active-active data center? And why is that, in your mind, a sort of pertinent and interesting use case for software-defined WANs?
Sure, Joe. So active-active data center refers to utilization of your all data center assets in a simultaneous way, where instances of the applications are running in multiple data centers. And you do that, the customers do that for optimal utilization of assets, but also for a load balancing and for absorption of variable demands, which might change from time to time. And the other reason that we've seen is geographical location may be more optimized for serving certain customer base or user base. So the active-active data center refers to any of these three reasons-driven environment where you are using your applications, virtualized or not, across multiple data centers simultaneously.
So Lee or Mark, one of you guys, active-active data centers, I think, in the past have been a pretty expensive proposition. Does SDN change that at all, or is this still for the sort of people with huge budgets?
Well, I think the network now enables, especially with SDN technologies, enables active-active in a much more cost-effective and easy to manage fashion. In the past, you'd have to set up a specific passive, the active passive data center where you'd have resources sitting idle, and with a more dynamic network, you can move to an environment where all your data center resources are active, and now you're load balancing across them, and more easily can fail over in an event of any downtime.
Just to add to that, Joe, too, is that the whole movement. You look at the whole movement towards the cloud and people's use of the clouds, and a lot of the clouds are starting out as private clouds, and there's certainly then there will be a movement strongly towards more of a hybrid cloud environment where parts of your environment are privatized and part exist within the cloud itself. And the whole point of that is to create a highly elastic environment, one that stretches and moves. It's very fluid in terms of how you use your resources and how your resources are assigned. And we saw this over the last 10 years develop within the server environment of virtualization, where virtual machines could be moved appropriately to servers that were more idle. So that drove utilization of servers up a great deal. But without software-defined networking, without bringing that elasticity to the network, then we really can't deliver on that cloud ideal, whether we're talking about a private cloud where multiple data centers are servicing all of your customers, all of your end customers, whether they're workers, whether they're partners, whether they're end customers themselves. So again, that's really very key to match the software-defined networking advancements to the advancements that we're seeing on the computing side of the fence.
Mm-hmm. Ashish, where does continuous availability kind of come in here? Is this about just keeping the apps up across these data centers?
That's right, but it's not just about the apps, right? So now that SDN fixes the network component to be more agile and flexible, you now have an opportunity to combine your applications infrastructure, your servers, your network, and storage all in a unified way, so that if you have to move an application, you have to make sure your storage is also in sync, and you have appropriate server infrastructure and network infrastructure that's available at the other data center. So the continuous availability refers to having all these resources available in a dynamic fashion so that the applications can move on demand for various reasons. It also adds the high availability component. So in the past, it's been primarily a DR conversation or active standby, active passive conversation. But what you need is active-active to support continuous availability. So that's where it comes into play, that your resources are always in sync, at least the state of the resources are always in sync, so that when you move any application, the corresponding, the compute, the storage, and the network resources are also ready to go.
Ashish, can you help make this kind of real for us with a customer example of maybe someone that's applied SDN to an active-active data center topology? Do you have a good kind of customer example?
Right. So so let's start with a customer. It's a large retail customer where there are multiple data centers in about a 60-70 mile range. So that's a nice distance from metro environment where your application latencies are sub 5 milliseconds. You can meet those demands of the application end-to-end latency of sub 5 milliseconds. So what this customer has to ensure is that first of all, let's start with the storage. Storage is always in sync. So for example, with EMC vPlex as one of the examples, you can keep all the storage in sync across both the data centers. In order to keep them in sync, you need a high-speed, low-latency network, which typically in optical transport solutions is ideal for. With such a short distance, you can easily run dark fiber or Lisa Lambda. And on top of that optical transport, you then provide Ethernet switches solutions to enforce the application policy. So imagine a case where you have an app, let's say an Oracle rack, or just with a VMware virtualization environment, and there are multiple different application flows across these two data centers. Some of it is just a storage vPlex flow, some of it is Oracle rack cluster sync flows, some of that is vMotion. All of those flows are going through your shared infrastructure. Your SDN now is making sure that all these different flows are getting their share of bandwidth and resources in appropriate manner in terms of if there are multiple paths, the right low latency path versus the best effort flow can take a higher latency path, the amount of bandwidth that's carved out for you, which may or may not change dynamically. For example, if you add new storage, there might be an initial peak in the demand that you need to give to your storage traffic. How do you do that in a dynamic way? By deprioritizing some other traffic. So tying in that application to the network, to the storage, between the data centers, getting their end-to-end visibility is how our customer has deployed this solution.
So I'm just going to try to break that down a little bit. So the challenge here, I want to understand what the customer problem was. So the main customer problem in the example you just outlined was visibility into the network traffic and that they needed to be able to prioritize certain traffic. Was that their major problem?
Well, at the high level, the business problem was that how do I ensure that the infrastructure I put in is sufficient for my application SLA? If you dig down a lower level, okay, to meet the application SLAs, you need certain demand from your certain SLAs from your network, which, as you said, is about what is my end-to-end network look like, what's the end-to-end capacity, latency, etc. And then how do I ensure that right application flows get the right SLAs in terms of bandwidth or latency? So yeah, there's a business problem and there is an underlying network challenge that has to be met to meet that business problem.
Okay. So in the example of that customer, they weren't meeting their application SLA, basically.
Correct. When they were deploying the application, they were not able to meet the application SLAs without having an end-to-end visibility into the underlying infrastructure.
Got it. Okay. So while we've been chatting, I just launched a poll for the audience here. The question is, what are your plans for active data centers in your WAN environment? The possible answers were currently using data centers in active WAN fashion for at least one application, or in planning and the implementation stage, or will consider at some point in the near future, and lastly, not under consideration, don't see a need. So the results here, I'm sharing those with you guys now, so you should be able to see them on your screen. Lee, Mark, looking at these numbers here, anything surprising? What jumps out at you?
You know, I think that you know, it doesn't surprise me that it's relatively early stage in terms of active. 15% starting, or 15% using, and then 28% planning. So that's a nice group of people who are certainly considering and have adopted active.
I think also could represent too a movement towards the cloud, where maybe they are not considering their own private active data centers, but they're considering tighter linkages between their single data center and other data centers of service providers. And that could be multiple service providers in the case of different application-specific service providers in the cloud, or maybe one cloud provider that's providing more of a soup to nuts application environment for them. So I think you could see a reflection too of not wanting to expand their private data center collection, but more of an incorporation of a hybrid environment as well.
Yeah, that's a good point. Ashish, how are you seeing that trend?
I think yes, I agree with Lee and Mark's comments, and we are also seeing a lot more interest. As you see, 40% are that do think that in the future they will see a need. So a good split between 40% of either planning or using it and 40% seeing a need. That's consistent with what we are seeing. We are seeing an adoption curve that's increasing in our enterprise customers.
Great. Okay. So I think we've looked a little bit at some of the benefits here. I am interested in some of our survey results around OPEX and CAPEX reductions. It's something that we see sort of the C-suite interested in, but sort of IT managers, network architects not necessarily understanding that yet. Maybe Mark, can you kind of just explain the sort of reduced OPEX and CAPEX story with SDN?
Yeah, I think a lot of the focus and we've seen, when we see this in the last bullet on this showing slide, is reduced CAPEX through merchant hardware and such, is there is a, I wouldn't call it a myth, because there's certainly a movement towards bringing networking software onto server environments under the control of hypervisors and orchestrators, so that there is certainly a movement for a lot of the control structure to move towards being executed on hardware that's either already available in data centers or is hardware that could be easily swapped out vendor to vendor and such, so it presents a very nice open systems opportunity and a chance to save some money. And that does relieve a lot of control burden on the part of traditional networking hardware, where we've seen all the control and forwarding all bundled into boxes. And we've also seen, obviously, with network services like application delivery and WAN optimization and such, we've seen those delivered via appliances, hardware-based boxes with some software on top of them. And we are seeing a strong move towards moving that software up into, shall we say, more competitive hardware capability. So there is some potential savings for CAPEX there. But the reality is that if you look at 5-year TCOs, and for most organizations, the reality is that OPEX is 70 to 80% of the total cost of operating a network. So from that perspective, OPEX, your WAN cost, your bandwidth cost is an operating expense. Your staff cost is an operating expense. So, with the large bulk of expense being focused on the operation side of the fence, most of the benefit and the biggest gains, you save 10% in OPEX via SDN, you're saving, all of a sudden 7-8 percentage points off your network budget. You save 10% on your capex, what are you saving? You're saving a couple of percentage points. So from that standpoint, any reduction through automation, through virtualization, staff that's being able to be leveraged across multiple environments where you have networking and computing, a CCIE that's also certified on VMware, things like that go a long way to saving in staffing. And also, we talked about this earlier in terms of the WAN itself, better using bandwidth, not over provisioning bandwidth to account for the large, that big data analysis or the big data replication event that happens every night or something like that. But you improve your utilization of your bandwidth, and suddenly you're able to get away with less bandwidth overall. So that dramatically reduces a big part of the operating expense. So OPEX compared to CAPEX, the focus should be on OPEX, not necessarily the CAPEX part of the fence. Although Lord knows we do spend billions of dollars a year on networking devices, that really will not change. We'll need a lot of speed. We'll need a lot of great intelligence to react to all the directions that are coming from applications. So networking hardware will continue to be very intelligent, and as a result, will be rather specialized. An open vSwitch sitting on a server is not going to replace a 100 gig capable data center switch in our data center. So from that perspective, again, OPEX should be the focus, not necessarily the CAPEX savings of SDN.
Got it. Lee, have you seen yet out there in the market anyone being able to sort of drive higher revenue through this idea of offering differentiated SLAs, or is it too early to see that yet?
I think it's a little early there. You're speaking from the carrier standpoint. I mean, they're looking to transform their own networks to provide services to be able to move towards more bandwidth on demand and variable SLA type services. But AT&T and Verizon tend to move fairly slowly there.
Is there a viewpoint in here sort of between data centers on the enterprise side, Ashish? I'm curious if there's a thought about driving revenue there.
No, I think that's so. I think one of the set of customers we work with are data centers and hosting providers, and for them, they are very interested in driving revenue. So these are customers who have multiple data centers and are providing connectivity services to their clients. We also see large private enterprises, IT departments acting as a network, acting as internal to the internal clients, providing network as a service. So in both these cases, they are able to, and especially in the first case, they're able to offer the available bandwidth, let's say, to the highest bidder. So we have a customer that has been very excited to say, oh, if I have a 10 gig pipe is only available, bandwidth is 2 gig, I'll give it to the highest bidder. Or other way they are approaching it is that I have multiple paths available, and if somebody wants to pay for a redundant path with automatic failover capabilities in the optical domain, they'll pay a premium. But if somebody wants a best effort service, in which case when the link dies, the traffic doesn't continue, they can now get a lower end of the cost service. So data center providers are very interested in this higher revenue model. But this concept of using network as a pool of resources to offer differentiated SLAs is applicable even for private cloud use cases, because when you have competing applications, there are weights or priorities or values that you put in to these applications. And tying those values to the infrastructure SLAs is a key component of this solution, of using the resources in an optimal manner without over-provisioning it.
And have you seen people kind of do that mapping process yet?
Yeah, that's what we are at Velo. We are enabling. So, for example, we are very focused on specific use cases, and one being active data center with EMC VPlex. So we have an EMC VPlex app that's coming out. What that'll do is it'll tie to the reflex flows, reflex controller on the storage side, understand what are the different flows on the reflex side, as well as competing with other application flows, such as your regular LAN flows going across the data center, or Oracle RAC flows, or VMware flows, and an automated way, carve out different amount of bandwidth that can change dynamically through policies, so that you always get the right SLAs for your right application. Yeah, we are offering such a solution, and our customers are very excited about the ability to do that.
Just on your point, what was that, Mark?
Yeah, it was Mark. Joe, I ran into a very interesting example a month ago, and you know, hard to believe, and maybe some of the people on the call may even laugh at the solution, but I was talking to a service bureau about their networking capabilities, and they had some high-speed links between two active data centers, and in their, as a service bureau, it was becoming more and more apparent that, you know, they had to have, you know, data replication was everything to them. They had to have the same data available in both sites, and their sites were 1,000 miles apart, and you know, they just were not able to budget for the kind of bandwidth required to do that kind of replication. And so what they found themselves doing for the last year or two was literally shipping storage devices. They had an extra set of storage devices that traveled between the two sites on a truck that would literally be backed up locally in one data center, shipped to the other one, and that kept the data within a few days of timeliness. But you know, they really had to move to a real-time situation, and so they were able to, through software-defined networking solutions, they were able to, again, allocate the right kind of bandwidth without impacting existing applications, and they were actually able to keep the same bandwidth that they had previously without having to, again, break the budget and buying more bandwidth. And they moved more towards a real-time synchronization model, and as a result, it's certainly enhanced their business because they can service their customers accurately all the time now, instead of just, you know, well, it's for the perfect information you need to go to this data center, for the older information you need to go to that data center. And as a result, that's attracted more data sources for them, driving some more revenue.
Right, rather than having to wait on FedEx to get the data. Yeah.
Yeah. You know, it's amazing in this day and age you'd even think about something like that, but it worked for them and it was economical. Luckily, the truck was never hijacked or broke down or anything like that. But again, you can see the kind of crude solutions people will come up with to kind of get over some of the problems created by lack of bandwidth and lack of accuracy and such.
Yeah. You piqued my interest a little bit with the idea of being able to kind of give bandwidth to the highest bidder. What did you have in mind there? Is that specifically a service provider, like the hosting companies or service providers, or was that something that you imagine global businesses doing? Can you kind of explain that a bit more?
Right. So these are not your traditional telcos that we're talking to. We're talking to certain data center providers. So like the Equinixes of the world. So we're talking to one such data center providers in Asia, where they have multiple global data centers, and their interest is that they are providing connectivity services to their clients, and sometimes, depending on the market needs, let's say there is a large financial set of activities going on, there is a peak demand that may come up that requires extra 10 gig of bandwidth, let's say from Hong Kong to Singapore, or from Singapore to Tokyo, for example. And the customer of ours has multiple dark fibers, which gives you a certain amount of bandwidth. And when you are reaching the peak, you have, let's say, only out of 100 gig, you have only 15 gig remaining, and the demand is picking up. You can just run a regular auction where, say, okay, I have 5 gig available to this at this level, 5 gig available at this level, and so on. And the idea of doing that is very attractive, but even more attractive is doing that in a way that's tied to your billing system, that's tied to your provisioning system in an automated way, such that as these demands go up and down, you can algorithmically adjust your offerings, your pricing, and so on, and provisioning on the fly. That's what's very attractive to this data center provider customer.
Cool. So we wanted to dig into it a little bit more on some case studies. I think we have some examples here: financial, healthcare, big data analytics. In the healthcare space, we haven't touched on that. Ashish, do you guys have any customers in healthcare that are interested in this model?
Yeah, so we are talking to an insurance provider where, again, with multiple data center, and their idea is that how do I make my network or overall solution more agile and respond to the changing needs dynamically. So the component that we help in is connecting the available bandwidth and managing the bandwidth between the data centers. So, for example, I'll give you a real-life example where, let's say there is a natural disaster in one part of the country, which has been shown to drive increased insurance quotation rates and the likes in rest of the country, frankly, because people are like, oh, I'm potentially underinsured. So those are the kind of peaks that this customer has to plan for. And if you over-provision your network, you are paying for more than what you need for most of the time. So for this customer, what's interesting is that how do I observe my peak demand without over-provisioning it? Because I have the ability to reduce the available bandwidth to a low priority application. So the customer might have the quotation system, the premium, the claims processing system, and in general the web data and data analytics system. And so depending on the business need at that time of the day or that time of the year, you can dynamically allocate different amounts of bandwidth to meet your business objectives at that time. So if you need more resources allocated to your quotation system, sure, you can deprioritize some of your other part of the network. So that's where the use case comes from. They're tying in the business application to underlying network utilization. Right.
And then I'm interested, there's an example here around how this can actually help compliance too. So you're compliant all the time versus just once a month. Why would it have been just once a month in the past, and how? Can you explain that?
So that's an example of what the previous case where we said, right, where the data is shipped by trucks, where how do you ensure that your data is always in sync, that you're always compliant 24/7 by having the visibility end-to-end? So once you have active data centers, you also need the tie-in back to the application because you're running compliance and audits at the application layer. The ability to have the visibility into the underlying storage, into the underlying network, into the SLAs provided by the infrastructure is important so that that's when you can be assured that any time of the day I'm compliant and I'm auditable, and not when, after this Monday when my data is in sync, I'm compliant to these healthcare regulations. So that's where, again, this continuous availability is tied to compliance and it's tied to SDN.
So there's some interesting questions coming in from the audience, guys, that I want to try to include here. One of them, Lee, here's a question for you. Does this technology reduce the need for WAN optimization products?
I think that's an interesting question. WAN optimization is a different technology. It is interrelated, but I think that you're still going to need your Riverbed and other WAN optimization type solutions in many applications.
Why?
You still need to optimize and prioritize your data. I mean, the solutions we're talking about are really data center to data center. So it's not it doesn't really address your branch and other regional office prioritization issues.
And Joe, if I might add to this point, is that the goal of WAN optimization is reduce the footprint of the data, which is a complementary technique to what we're talking about, which is carving out the available bandwidth in a more efficient way. And also, when we're talking active data centers, these are typically low latency environments, sub 5 milliseconds, and the WAN optimization solutions are better optimized, as we just said, for the branch traffic where latency is of less importance, because any kind of WAN optimization will add latency, which would make them not applicable for the active low synchronous use cases. So it's a complementary thing, and the use cases are, for the most part, non-overlapping.
Got it. Ashish, just an interesting question for you, from the audience, around the idea of kind of trust boundaries and handoff for SDN across data center WANs within an enterprise. But then let's assume the data center that are managed by different cloud providers. The question is, are there new DSCP codes or other fields to support cloud provider SLA handover?
That's an excellent point. Yes. So the initial solutions you will see will be for the private cloud environments, because these the problems that you bring up are solved by the nature of having a single administrative domain. As we go towards more inter-domain or across different cloud environments, yes, you will need those tenancy handover or the trust boundary isolation points. So yes, one way to do that is through the DHCP bits. The other way to do that is that the orchestration layer handoff. And there is no one right answer yet. I think there are multiple approaches, and we'll see many of those evolve. But these are, so one of our customers that we're talking to has, in this case, it's the same customer, but they have different country regulations. So they have to maintain different domains across different countries for trust boundary sake. So there, the proposed the model for this trust boundary is through the orchestration layer. You have an orchestration layer handoff, if you will, to delineate which site owns what, and then you have appropriate data path marking, if you will. So in the data path, that's the question is about how do you mark the package through DHCP bits. Yes, that has to be done, but you need to also have orchestration layer handoff in conjunction for a smooth handoff. And then we will see more of these solutions evolve in next few months.
Interesting. Lee, this is a sort of broader question about monetizing SDN. This audience member asks, at some point, one cannot provide both cost and bandwidth benefits, as QoS is about starving one traffic over another.
Well, I mean, I think that there's trade-offs in any technology, but I mean, the flexibility of the technology means you can actually choose if you can prioritize traffic and move traffic, bulk traffic to times where your pipe isn't full. You can actually do both, and I think it is a little bit about it is about saving costs, and it is about improving the operational efficiencies of your data center.
Right.
I'll give you a specific example that's very real for our customers is how to avoid over-provisioning. So let's say there is a class of application which requires full protection. So in the olden days, you would dedicate a fiber, or at least a part of the fiber, for that application. Here, you could use that fiber bandwidth for low priority traffic, but if there is a fiber cut, then you would drop that and let the high priority flow continue. So picking and choosing, as Lee said, is an important part of the consideration.
Got it.
It's also a consideration, too, in terms of just the visibility into the applications that are using the network, and then the micromanagement that must follow in terms of assigning policies to how the network deals with all the different applications. Our application environment is a very fluid environment where there's a lot of different applications buying at any one moment and any 1 week or month for that bandwidth. So, getting out of the micromanagement business is a good thing for operational folks. If you ask in polls, you actually see very low turn-on rates for QoS facilities within most networks. I congratulate those that are using it effectively and have full control over their applications and their bandwidth. That's fantastic. But the reality is that came at a price in terms of staff dedicated to the visibility of those applications and what to do with the network. So with SDN and the automation functions that go along with it and the analytics that feed into an SDN functionality, is that's done on the fly. And as we move towards big data analytics and things like that, where it drives a lot of real-time data needs, then suddenly this change on the fly capability is very, very key, because that's something that even the best of operational functions couldn't keep up with that demand.
Yeah. Well, perhaps there's just some some reluctance or apprehension on the part of network managers to rely on that automation, you know. So while we had the poll launched here, the question was, what's the biggest obstacle in transitioning to active data centers? The answers were they don't know where to start. Data center challenges, e.g. distance limitation, bandwidth, etc. Operational complexity, and last of all, lack of interoperability between different solutions. And the results from the audience I will share with you right now. Lee and Mark, again, curious to get your thoughts on the results here. 50%, so half of the people listening, said operational complexity is the biggest obstacle to active data centers.
Yeah, that's not a surprise to me, Joe. In terms of, all these are sort of interrelated. You need to figure out where to start. You need to figure out, what your criteria are, allocate sufficient budget, and some of these solutions are technically complex, and there's a lot of them, so you need to sort through the complexity, and that's always the challenge for the technology suppliers, is to help customers do that.
Right.
Yeah,
go on, Mark.
Yeah, and we certainly see the same thing reflected in networking, not even within data centers, but even beyond the data center in terms of the overall complexity of operating the network itself. And that's the reason why before that example where a lot of people don't have QoS turned on and such is because it's just a very complicated task. And let's face it, people are already busy fighting a lot of fires as it is and being ready for that next application or adding new devices to their network all the time. So again, making that transition, any major transition like to an active data center, is a very complex undertaking on top of an already pretty strong burden.
Yeah, okay, so given half the audience here worrying about the sort of complexity issues, which sounds fair enough, what are some of the ways to put your best foot forward, Ashish, when starting down this road?
Yeah, I would start with application as the top of the list, saying, okay, identify what are your applications first, and maybe pick one or two, and identify the requirement and say, okay, what does this mean? If I need to make this business application active, what does it mean for the rest of the infrastructure? And from servers to storage and so on, but also the bandwidth for the network, the latency requirements, the security and the resiliency requirement. And then you go into down this list, which is, okay, then identify your data center locations, because active data applications have certain latency constraints, typically 5 milliseconds, sometimes 10. And so identifying those strategic locations, especially many customers as they look at getting new data centers, the location of the data center becomes an important point, not just over a cost point of view, but also the supportability of these active data centers. So metro distances, it's possible to do active. If you go over 500 kilometers, it becomes a little tricky, again, not from network point of view, primarily from application constraints point of view. And so those are important considerations as you go towards this journey. And then, as we saw, operational complexity being the main problem for this, and SDN has a big opportunity to solve that, look at such a solution. Look at an open networking SDN solution where you get end-to-end visibility to reduce your complexity of deployment. You get the application tie-in through the right set of APIs, and then make sure that you can drive your application SLAs end-to-end. And the final piece that will be important would be, how do I transition from my existing environment to the new environment? So interoperability with the existing environment, applications, storage, network, and coordination between the cross-functional teams. I think those complete the picture in terms of what are the checkpoint items you need to look at as you embark on this journey.
Lee, just from a customer standpoint, I'm trying to identify open networking platforms. Are there other things that I should think about when I'm with a view to sort of evaluating something that's truly open?
Well, I think you want to look at support for standards, both de facto standards and standards bodies based standards. You want to look at interoperability. So openness really means what does a given product work with other products that you may want to use. How do the management tools tie in to the other management capabilities that you have in the network? And of course, security is also always top of mind for many IT professionals.
Cool.
I think too, Joe, is that adding to what Lee just said, it's industry standards and such give you a certain amount of flexibility, certainly support for things like OpenFlow within network devices and such, and OpenFlow control functions within the controller certainly give you, but you have to look at, you're looking at your vendors, looking at partnerships, looking at application validation programs they may have, things that present a larger ecosystem so that when you buy from one vendor, you're buying their ecosystem. As I had one customer I was interviewing a month or so ago for an SDN solutions, as they said, test the company, don't just test the product. And I think that's really a good advice here in terms of understanding that when you do buy from one vendor, again, those partnerships are going to come in very key down the road in those application validation programs, those application kits, industry standard API support. Those are all the things that you're buying with that company when you're subscribing to them.
Right. Yeah, and there's multiple of these different ecosystems out there, so around different standards, so it's definitely worth digging in and paying attention to that. This is a particularly, sorry, go on.
Oh, no, it's because the integration burden grows for customers buying products, so the best you can manage that integration burden, no matter how much you've tried to minimize vendors in your network over the last few years, or even within your data center within the last few years, that set is going to grow larger. It's just a fact of life. Not every vendor can do everything. So you're going to be blending in more and more applications and services on top of your network core within your data center. So again, that integration burden grows larger as we go forward in the software-defined world. And as a result, these partnerships, open standards, as Lee mentioned, these things are going to be that much more critical to relieve some of that integration burden on you.
Right. Ashish, we're closing up on the hour. I want to get a few more questions answered from the audience here. One of them, I think, is particularly kind of weedy question, but maybe nevertheless interesting. It is, do you think existing solutions support enough flow entries for WAN applications? And if so, at what granularity would you define WAN flows?
That's an excellent question, and I think you see a lot of focus in the WAN today because the hardware is capable of supporting WAN entries. Google has done that for their own data centers. We are providing the WAN solutions because the hardware is capable. And I think the advantage of WAN is that you can do it at a more aggregate level, at application flow level, and doesn't have to be at the, let's say, top of rack data center switch level, which can go up to hundreds of thousands of flows. So for the WAN, yes, the technology is ready today, and the problem is apparent as we saw today. As the hardware capability on the flow entries matures, you will see a lot more focus on the industry, on the whole industry, on the core data center with OpenFlow.
And then another question, this is on the sort of latency issue. This person asks, 5 milliseconds means you're not talking about a long distance from a disaster recovery perspective. How can you leverage SDN for active-active with distances more like 1,500 miles?
So the question there is, so I think it depends on the application SLAs, right? So the 5 millisecond or 10 millisecond latency is usually a constraint of the applications. For example, EMC vPlex has that 5 millisecond round trip latency constraint to have active-active storage. Or VMware has, for vMotion, live vMotion, it was 5, now it's about 10 millisecond as of vSphere 5. So whatever the application constraints are, the network should be able to support that. So the limitation of a few hundred kilometers comes from that. If you go to 1,500 kilometers, yes, you're looking at a more async environment, and your network can absolutely support that. It's not a network constraint. It's really what your application wants you to support. 1,500 kilometers, physics doesn't allow you to go less than 5 or 10 milliseconds. That's just physics. So your network should be able to handle any requirements that the physics can support. The reason we are talking about 5 to 10 milliseconds today is the active part of the focus is constrained to that latency. We don't see active. So the DR will always stay for the longer distance piece, but for the metro environments and a few 100-kilometer environments, we are seeing a big transition into active. So it's both.
Cool, thank you. Lee, this is a follow-up on your question around focusing on open standards. This person, I think, is realizing that there's a lot of different options out there. They ask, there's a myriad of open networking standards, alliances, different cloud providers, and networking vendors leaning towards one or other standard. Should we put around 50% attention on open standards and keep core competencies or proprietary stuff at 50%? Is that fair?
You know, I think that's not a bad metric. I mean, obviously it's going to depend on each individual organization and where they are with their installed network and what their key goals are. But, you know, this is all going to be an evolution for anyone who has an existing network. So you do have to look at your legacy and your incumbent suppliers and, you know, how you're going to migrate your network going forward. So it's going to be some mix of, you know, quote unquote proprietary as well as some open solutions.
Mark, there's a question here on OpenFlow. Will OpenFlow domains have a challenge to work with the rest of the world?
Yeah, we're already seeing that challenge, certainly. You know, and there seems to be a lot of, you know, nice rallying around the overlay approach, where, you know, you're using SDN in certain situations across an existing infrastructure, and that makes perfect sense. And quite frankly, for any technology to succeed in networking, as we've seen over the years, is technologies that blend in with the existing are always more successful than those that kind of try to change the status quo dramatically. So from that standpoint, you know, OpenFlow is a bare minimum requirement for any SDN solution, quite frankly. You know, whether it's 50% or 70% or something like that, I think it is very key. You know, you're going to need to have proprietary technology mixed into your solutions. But where those proprietary technologies meet, you are certainly going to require technologies like OpenFlow or RESTful APIs at the application level, standards that present some sense as some easy way of integrating different solutions together, and some way for the vendors to proving that their solutions work with other vendors, because that, again, is going to relieve that integration burden we mentioned earlier. And OpenFlow, to a great extent, I think it's interesting to watch the controller, you know, Open Daylight and such, and the advancements in controllers, and that's starting to consolidate around a certain set, which is nice. Not everyone's doing their own controller. There's starting to be some consolidation there. Certainly, we've seen a lot of OpenFlow support, and we're seeing the plug fests are very interesting to watch, and a lot of support for obviously 1.0, 1.1, 1.3 now is the stabilized OpenFlow solution. So you're seeing good plug fest support for 1.3 solutions. So again, those all point to, again, nice integration amongst the different OpenFlow supporters that are out there. But what's above the OpenFlow the controller wards, if you would, you know, those applications, virtualization, data replication. What's aside of it, you know, the incorporation of analytics into the mix. You know, that's a new thing. And what's below OpenFlow, that is, like, for instance, relative to this conversation, you know, the mix of optical with OpenFlow and the use of, you know, the fine advancements we've seen in optical over the years mixed in with an OpenFlow solution. You know, those are much more interesting to me than necessarily tracking OpenFlow support in devices or the controller wars that are going on.
Yeah, exactly, because it ties to real kind of use cases and business challenges. So Ashish, sort of summing up for us, what do you expect to see happen with SDN across data center WANs over the next 3 to 5 years? How do you see this panning out?
I think both for SDN and data center WANs and in general SDN, what you will see is use case focus solutions will succeed. So as if you in an ideal world or in a world that's a few years out, we see different controller-based solutions optimized for different problem solving. There is no God box SDN, and so I think the success will come to focused use cases that solves a real problem. Specifically on the data center WANs, you will see much more tighter integration of optical and Ethernet through native OpenFlow, and you will see a lot more of application tie-in on the northbound side for specific business applications driving the specific dynamic policies and provisioning at the on the underlying network. So I think those are the two things I see in next few years.
Great. Thank you to my panelists. You guys have been wonderful. Thank you to the audience for tuning in, and we look forward to the next one.